All right. So according to my notes, we finished Monday with example 7. Is that correct? So now we're moving on to example 8. So example 8 reads, verify that x equals minus I is a zero of a polynomial function, f of x, and find all the other zeros. So what's the degree of our polynomial function? Anybody know? 4. So how many zeros does that polynomial function have? 4, right? The number of zeros equals the degree of the polynomial. Some of the zeros can be repeating zeros, right? But there are 4. All right, so first step, verify that x equals minus I is the zero of the polynomial. So we have f of minus I is equal to 4 times minus I to the 4th minus 8 times minus I cubed plus 9 times minus I squared minus 8 times minus I plus 5. We got to show that on the right hand side is equal to 0. Minus 8, 9 times minus I squared plus 5. Right? So minus I to the 4th, right, is the same as minus 1 times I to the 4th, which is the same as minus 1 to the 4th times I to the 4th. Minus 1 to the 4th is 1. I to the 4th is 1. 1 times 1 is 1. Okay. So this first term is equal to 4 times 1. Okay. Minus I cubed is equal to minus 1 times I cubed. Oops. Is equal to minus 1 times I quantity cubed, which is minus 1 cubed times I cubed. And minus 1 cubed is minus 1. And I cubed is equal to negative I, which is minus 1 times I. Minus 1 times minus 1 is plus 1. So we just have I. So the second term is equal to minus 8I. The third term, right, this is minus 1 times I, minus 1 squared is 1, and I squared is minus 1. So the third term is equal to 9 times minus 1. And then minus 8 times minus 1 is 8I, and then we have plus 5. So if we add up all the real terms with just real numbers, we have 4 minus 9, which is negative 5, and negative 5 plus 5 is 0. And we have minus 8I plus 8I, which is 0. So f of minus I is equal to 0. So x equals I, minus I is indeed a root. Okay? So x equals minus I is a root, and complex roots come in pairs, right? So if x equals minus I is a root, what else is a root? I say root. Root is another word for 0. Sorry. So if x equals minus I is a 0, what else is a 0? Right? Minus I is the same as 0 minus I. So its conjugate is 0 plus I, which is just I. So minus I is a root, so is then x equals I. Okay. Complex roots come in pairs. Okay. So x equals minus I and x equals I are zeros of f of x. Right? So those are two zeros of our fourth degree polynomial. So now we just got to find the other two. Okay. Well, if x equals minus I is a zero, then x plus I is a factor, right? Remember the factor theorem, top of page 1. Okay. So if x equals minus I is a zero, then x plus I is a factor. And if x equals I is a zero, then x minus I is a factor. So if we multiply these two factors, right, this is of the form a plus b times a minus b. A plus b times a minus b is a squared minus b squared, right? So this is equal to x squared minus I squared. I squared is negative 1. I mean, you're going to see me do this over and over and over again, so you should get used to it, right? You should know before you can write it on the board. Minus a negative 1 is plus 1. So x plus I times x minus I is equal to x squared plus 1. Okay. So our fourth degree polynomial, 4x to the fourth minus 8x cubed plus 9x squared minus 8x plus 5 is equal to x squared plus 1 times some unknown quadratic. Okay. You might want to leave a space down there underneath that row, okay? Because we're going to figure out what q of x is. Okay? So how do we find out what q of x is? Well, we divide both sides by x squared plus 1, right? So we have q of x is equal to our fourth degree polynomial divided by x squared plus 1. How do we carry out that division? Will you raise your hand, Jake?
Yeah. The minus 9 to the x to the third power is then minus 8.
4x to the fourth minus 8x cubed plus 9x squared minus 8x plus 5 is equal to x squared plus 1. You're talking about this line right here?
Yeah. The fraction you made it 9.
4x to the fourth. Oh, sorry. I got ahead of myself. I was looking at the next 9. Thank you. So we have 4x to the fourth minus 8x cubed plus 9x squared minus 8x plus 5 x squared plus 1. How do we carry out that division? Give me an L. Give me an O. Give me an N. Give me a G. What do you spell? Long division, right? So we have to divide our fourth degree polynomial, right? This could very well could be an exam question tomorrow. Form this long division. Okay? And when you perform the long division, I'm not going to carry out all the steps, but you get the quotient 4x squared minus 8x plus 5. Right. This very well could be an exam question tomorrow. Right? That's what I mean. You need to know long division. I'll have you divide two polynomials. Okay. So our fourth degree polynomial over here is equal to x squared plus 1 times 4x squared minus 8x plus 5. So our fourth degree polynomial can be written as those two factors. Okay? And we already know x squared plus 1 factors into x plus I times x minus I. And x equals minus I and x equals I are zeros. Well, we got to find out what are the values of x, right, that make this factor equal to 0. And those values of x that make this factor equal to 0 are the two remaining zeros of our original polynomial. Okay? So, we got to set that quadratic equal to 0. And then the question remains, you know, can you factor this with real numbers, right? Or you got to use the quadratic formula. Okay. And turns out you got to use the quadratic formula. So A is equal to 4, B is equal to negative 8, C is equal to 5. So to find the last two zeros, okay, gotta use the quadratic formula. X is equal to negative b plus or minus the square root b squared minus 4 times a times c over 2 times a. And now you gotta plug in and do the arithmetic correctly. Okay? So negative b is the negative of negative 8. B squared is minus 8 squared. We have minus 4 times a, which is 4, times c, which is 5, all divided by 2 times a, which is 2 times 4. So far, so good. So now it's arithmetic. So negative 8 is plus 8. Negative 8 squared is 64. And minus 4 times 5 is minus 80. And 2 times 4 is 80. So 64 minus 80 is the square root of minus 16, right? So 64 minus 8 is negative 16. And square root of negative 16, oops, this is plus or minus, isn't it? So where did I drop the plus, the minus? So this is supposed to be plus and minus. Square root of 16 reduces to 4i. Right? Square root of minus 1 is I. Square root of 16 is 4. Divided by 8. So we have x is equal to, so remember you got to divide each of these terms in the numerator by 8. And so we get x is equal to 1 plus or minus 1/2 I. So the last two zeros of our fourth degree polynomial function are x equals 1 plus 1/2 I, and x equals 1 minus 1/2 I are zeros of f of x. The first two are x equals I and x equals minus I. And the last two are x equals 1 plus 1/2 I and x equals 1 minus 1/2 I. So this fourth degree polynomial, right, all four zeros are complex numbers. Any questions on that, ladies and gentlemen? Okay. I'm probably glad this material is not going to be on the exam. Few more weeks to soak it in. So let's take a look at example 9. One solution to the equation, right? Fourth degree polynomial equals 0 is a complex number x equals 1 plus 2I. Determine all the solutions to this equation. So you're given x equals 1 plus 2I is a 0 to that equation. Right? It's one value of x that makes the left-hand side equal to 0. What's another value of x?
1 minus 2i.
Yeah, the conjugate, right? So if you know x equal 1 plus 2I is a 0, then x equal 1 minus 2I is a 0. So those are two solutions to that equation. Those are two values of x that make the left-hand side equal to 0. We got to determine what the other two solutions are, right? It's a fourth degree polynomial, so there are 4 solutions. Well, the factors that go with these two zeros are x minus 1 minus 2I and x minus 1 plus 2I, right? To get the factors, you got to move everything from the right-hand side to the left-hand side, right? Are the corresponding factors and so this fourth degree polynomial is equal to this factor times an unknown quadratic. Okay? So x to the fourth minus 6x cubed plus 14x squared minus 22x plus 5 is equal to this first factor times the second factor, x minus 1 plus 2I, times an unknown quadratic. So we're going to end up doing long division again. Okay? So we got to multiply this out so that we can divide our fourth degree polynomial by the product. So this could be an exam question tomorrow, right? Multiply x minus 1 minus 2I times x minus 1 plus 2I. And I showed you two different ways of carrying out that multiplication. I told you my preference was to set it up as a difference of squares. A minus b times a plus b, which is equal to a squared minus b squared. So I'm going to group the x minus 1s, and so I have x minus 1 in parentheses minus 2y times x minus 1 in parentheses plus 2y. So this is of the form a minus b times a plus b, right? And a minus b times a plus b is a squared minus b squared. Well, my a in this case is x minus 1. So when you FOIL this, you get x minus 1 squared. And my b is 2y. So minus b squared is minus 2y squared. You do this enough times, it gets really fast, and you're not doing the long way where you can make a math error anywhere. All right, so you know x minus 1 squared is just x minus 1 times x minus 1. And then by the rules of exponents, 2i squared is equal to 2 squared, which is 4, times I squared. Now when you FOIL x minus 1 times x minus 1, you end up with x squared minus 2x plus 1. And then minus 4i squared is minus 4 times negative 1, right? I squared is negative 1. So you end up with x squared minus 2x. Minus 4 times negative 1 is 4, and 4 and 1 is 5. So if you look at this in reverse, the factors of x squared minus 2x plus 5 is these two factors, right? Complex numbers. So over here, we have x, right? This product is equal to x squared plus x squared minus 2x plus 5 times our unknown quadratic. So to figure out what q of x is, right, what a quadratic is, we have to divide this 4th degree polynomial by this quadratic to figure out what q of x is. And to do that, you got to do long division. So we have x squared minus 2x plus 5. Again, this could be an exam question tomorrow, right? Doing this long division. Goes into x to the 4th minus 6x cubed plus 14x squared minus 22x plus 5. So maybe let's do that long division for review. Okay? So, right? Under the long division symbol, the polynomial has to be descending powers of x, which it is, and the divisor has to be descending powers of x, right? So the first question is, how many times does x squared go into x to the 4th? So x to the 4th divided by x squared is x squared. So x squared goes into x to the 4th, x squared times. So you put that above the x squared in the above the x squared in the under the long division symbol. And now you multiply x squared times x squared minus 2x plus 5, the divisor. And when you distribute the x squared inside the parentheses, you get x to the 4th minus 2x cubed plus 5x squared. So that goes under the dividend. So you have x to the fourth minus 2x cubed plus 5x squared. And you subtract that from the dividend. And remember, the first column should go away. So we distribute the minus sign. You have x to the fourth minus x to the fourth, which is 0. You have minus 6x cubed plus 2x cubed, which is minus 4x cubed. And you have 14x squared minus 5x squared, which is 9x squared. And now you bring down the remainder of the dividend. You have minus 22x plus 5. And now you got to ask yourself, how many times is x squared going to minus 4x cubed? Well, minus 4x cubed divided by x squared is equal to minus 4x. So you put minus 4x up here. And now you got to multiply the divisor by x squared minus 2x plus 5. And when you do that, you multiply minus 4x times the divisor distribute the minus 4x inside the parentheses. You end up with minus 4x cubed plus 8x squared minus 20x. Minus 4x cubed plus 8x squared minus 20x. And that gets subtracted from the new dividend. And again, we do subtraction, that first column better go away. Minus 4x, so when you distribute the minus sign, you have minus 4x cubed plus 4x cubed, which is 0. 9x squared minus 8x squared, which is x squared, minus 22x plus 20x is minus 2x, and then you bring down the plus 5. The remainder is 0. That shouldn't be surprising because x squared minus 2x plus 5 is a factor of this fourth degree polynomial. And so how many times does x squared minus 2x plus 5 go into itself? Once. So we have plus 1. Remainder 0. So q of x over here is equal to the quotient over there, x squared minus 4x plus 1. So now we got to find the zeros of our fourth degree, find the zeros of our quadratic. Okay. Now, if that factors with real numbers, that's fine, but I don't think it does. So we set it equal to 0, and then we got to use the quadratic formula. Okay. So a is equal to 1 in this case, b is equal to -4, c is equal to plus 1. So x is equal to -b is the negative of -4 plus or minus the square root of b squared, which is -4 squared, minus 4 times a, which is 1, times c, which is 1, over 2 times a, which is 2 times 1. And now it's arithmetic. Negative of -4 is plus 4. And under the square root, -4 squared is 16. And -4 times 1 times 1 is -4 over 2. So in this example, the zeros of our quadratic are not complex numbers. They're real numbers. But they're irrational numbers because of the square root. So this is equal to 4 plus or minus the square root of 12 over 2. Well, square root of 12 is equal to 4 times 3, and the square root of 4 is 2. So the square root of 12 reduces to 2 times the square root of 3. And again, fraction bars are like division symbols. Division does not do addition and subtraction, so both those terms got to be divided by 2. So we have 4 over 2 plus or minus 2 root 3 over 2. 4 over 2 is 2. 2's cancel in the second fraction, and we're left with the square root of 3. So x equals 2 plus the square root of 3, and x equals 2 minus the square root of 3 are the remaining two solutions. To this equation. Okay. So x equals 1 plus 2y and x equals 1 minus 2y are two solutions to that equation. And x equals 2 plus square root of 3 and x equals 2 minus the square root of 3 are the two remaining solutions. And you'll notice that when we have polynomials or real numbers, and none of the coefficients has a radical in it, then the zeros involving irrational numbers come in pairs as well. Okay? As long as there's no radicals in the coefficients. All right. So we'll save example 10 for the first thing on Friday. Okay. So have a good day, and I will see you tomorrow.